Alright, how you guys doing out there in calculus land? This is Mr. Muscarella coming at you, and we're going to take a look at example 2, where we determine whether a series converges or diverges using the ratio test. Now let's just kind of recap the ratio test real quickly. Remember, it only works for series that do have positive terms, so you've got to make sure that the terms are all positive, and it converges rapidly, so you want to take a look for things such as this, where you have a factorial in the problem, so maybe you have n factorial, or an exponential, so maybe you have something like this, maybe n plus 1, your variable is going to be there located in the exponent. So when you see one of those two things or both of those two things, that's going to be a clue that you're going to start by using the ratio test. Now remember, it's going to converge absolutely if when you take the limit of the absolute value of this, you're going to get something less than 1. Now remember, this a sub n plus 1, that's going to be our formula with n plus 1 substituted in anywhere there's an n. And then this piece, a sub n, that's going to be your original formula. So from there, we're going to end up with something that's either greater than 1, or if we get infinity, well, sorry, thanks for playing, our series will not converge, but it will diverge. And of course, if we do get 1, then we've got to pick another test, because the ratio test doesn't tell us squat about this particular series. So let's take a look at this example and kind of play with this and see what we got. Ooh, wow, look at that. Determine whether this series converges or diverges. Look, we've got an exponent that's variable, we've got factorial, so definitely want to start by using the ratio test. Now, remember, anywhere there's an n, you're going to substitute n plus 1. So that's going to turn into, the numerator is going to be n plus 1, and then over n with an n plus 1 power. So make sure you do that in the exponent as well. And then your denominator, of course, will be n plus 1 factorial. So your numerator and denominator are going to change slightly. So that's going to be the a sub n plus 1 part in your formula. So as you go through your formula, just take your time and make sure you plug everything in appropriately. From there, once you got everything plugged in appropriately, now remember, n to the nth power or n factorial, that's this piece right here, that's your original. So when you've got everything plugged in appropriately, then you'll be able to move on to the next piece, which means take this denominator right here and rewrite that. You're going to take the reciprocal and just go ahead and write that next, because then algebraically we'll have some easier things to work with. Once we are all set with that, from there we're going to start using the limit process. But even before the limit process, check this out. We've got n plus 1 to the n plus 1 exponent. So this whole thing is going to actually change, and so is our n plus 1 factorial. Because we can rewrite n plus 1 factorial to just be n plus 1 times n factorial. And the n plus 1 to the n plus 1 power, like all of that mess, you can rewrite that as n plus 1 to the nth power times another just n plus 1, because it's that same idea. So this, when we rewrite that, that's going to end up doing giving us something that looks like this. Now, why do we want to do that? Well, because check this out. Our n factorials, boom, boom, they're gone. And then also, we're going to have this n plus 1 factor in the numerator and the denominator that also cancel out. So from there, this is going to look a lot nicer algebraically, because then we just are going to have n plus 1 to the nth power in the numerator over just n to the nth power. Now this might sneak up on you a little bit, because this is an old limit problem that you should recognize. This should be a form of a limit that you recognize. Some of you might recognize it right off the bat. Other people, it'll take you a second and you'll be like, oh yes, that was buried deep in my calculus brain. And what is that limit? Well, you should know that that's a special limit, and that limit is E. So that is the Euler number E, which of course is 2.7 blah blah blah, which we know is greater than 1. So since we get a value for our limit that is greater than 1, then that tells us, sorry, thanks for playing, but our series is going to diverge. So when you write your conclusion, you're going to have to make sure that you state, since the limit as n goes to infinity of a sub n plus 1 over a sub n is greater than 1, the series, and make sure you state what the series is that you're testing, then you have to say what it does. It diverges by the ratio test. If you leave off ratio test, no point for you. If you don't put the series and label it, no point for you. And of course, if you don't say diverge or converge, again, no point for you. So I pity the fool that don't put all those pieces in there, because then no points for you. So take your time, and you guys will be able to pick this up no problem. Just make sure that you remember that little old-fashioned piece right here where we had this limit of E. Surprise, it's sitting in there. Just one little thing to pull back from the depths of our calculus brain. All right, boys and girls, ladies and gentlemen, thank you for listening and watching today, and I will catch up with you again soon. Peace out.